So as we start our potentially our last review session for content review in module 1, and then post our first assessment next week, what we'd like to do is take a moment to review. I'm going to give you a scenario for a project. And I'm going to describe 2 constraints, 2 limitations. And based upon those 2 limitations, I want you to tell me anonymously, well, not anonymously, but not in front of the group. I want you to use chat from Zoom. So what we're going to do, I'm going to pause the recording and pause the screen share, but I'm going to post a question, and I want you to use the pull down. And by that, I mean this little gizmo. I want you to use pull down, and I want you to select my name so you're responding only to me. You will respond with one of 2 answers. Planning and development, you can say P and D, okay, which would be, oh shoot, you would say P and D, which means what? What type of software engineering model of collaboration is that? That's a whole category or type of software engineering model. Does anybody know what P and D stands for? The other
Planning and documentation.
Planning and documentation. Thank you very much. And then adaptive, right? So sometimes called agile. Okay. It could be an agile variant, AKA also known as adaptive, right? So those are your 2 answer choices. I want you to read. You're going to either respond with this or with the word adaptive. I think just keeping the broad category description. Agile is a specific type, and it's sort of like agile is to adaptive software engineering models are to this term is kind of like saying Kali is a type of Linux. Agile is like a whole category of software engineering models, but it's also a very specific type as well. It's like the grandfather, it's like the very first original adaptive model. So that's one point of confusion, is that when people talk about agile software engineering models, what they really mean to say is adaptive software engineering models, and agile is the first original. And then everything after that was sort of a variant of agile. In the same way that Linux was spawned, and then there were a whole series of different Linux after that, right? So I'm going to post this question. I'm going to pause the sharing, pause the recording. I'm going to post the question. I want you to respond in chat only to me with your answer. One of these 2 options, okay? So here's the question, and I'm going to type it out on screen though. This part I can record. What? Let's see. You must choose an SE model, a type of SE model, a type of software engineering model for your integrated development project. However, the programmers are inexperienced and no strong project leader is available. Those are the two constraints. Which type is best for these conditions? Okay, everybody see on screen?
Yeah.
And in case that didn't populate to my window, I'll push it here. So there's the question. I want you to hit the pull down so you're not responding to everybody. And then I'm gonna go ahead and half answered correctly, half answered incorrectly. For cases where you lack a strong project manager and you're dealing with team members who are relatively inexperienced, the planning and documentation, or P&D, software engineering models are your best choice. That's what we know from 30 years of train wrecks. And if you've looked at the links in our UC Berkeley software as a service videos in chapter 1, you've probably seen a $300 million Ariane rocket blow up mid-screen, $300 million gone from a single coding statement that was incorrect. One line of code, $300 million. No joke. Okay? So if you ever wondered whether or not what you do is important, boys and girls, software engineering is serious business. Okay. Does anyone have any questions about what we just covered or would like to understand? So where did I get that information? You can use agile or adaptive when you have experienced programmers, when programmers are always available and local to each other so they can work together, right? You have high quality programming tools and environments. Documentation is not a dominant part of the culture. The customers are always available. So not just only your teammates, but your customers are in the mix, right? The reverse is true for planning and document. Inexperienced programmers, you don't have a strong leader, and that's not in this list. That's actually up further here where it says it depends heavily upon the competencies of a strong manager. You got to have a person in charge. Okay. Regardless of which type of software engineering model, always remember, and I'm gonna modify this. I'm going to amend our study guide so that it reads, earliest P&D models include 5 important stages, and I'm gonna add the statement, coincidentally, agile and adaptive methods also include some flavor of these 5 stages as well. You just call them different things, okay? For example, they might call that component the requirements engineering phase or stage of an adaptive project, right? So explicitly, it's not worded in identical terms, but I'm going to update this one paragraph here because I want to make sure we're precisely accurate. You still have 5 important stages regardless of the type, but how they're explained in adaptive agile terms is a similar but not identical. Okay. Yes. All right. So let's go on. Any questions about what we just covered? Any questions or comments?
No questions.
So one of the things that we've come to understand about software engineering, and this is a point of confusion that novice programmers make, the type of programming you're doing is not, it's not specifically associated with one software engineering model versus another. In the very earliest days of computing history, programming languages were of a type called procedural programming languages. If you have already finished CSC 333 programming languages, you probably learned that there are procedural programming languages versus object-oriented programming languages. But that doesn't mean that most of the programming languages that are used in predictive models are procedural, and the adaptive models make the most use of object-oriented programming languages. It's important to understand that object-oriented programming languages were a benefit to either type of software engineering model, and it's an expectation regardless of what flavor of project and collaboration you want to use when you're building your integrated solution. So I'm going to call that OOP, right? Object-oriented programming. Is there another more hip or modern term for OOP? OOP? Some might call it functional programming as opposed to or modular programming instead of object-oriented programming. Same, well, not entirely the same, but close, right? If you have procedural or functional, no, I'm sorry, functional or modular programming and the right criteria are included, additional criteria are included, modular or functional programming on steroids, then you have the basis of object-oriented programming. A lot of coding shops have dropped the practice of using input-output tables. And that's because with agile adaptive methods, people think, that's old school. It's still a good idea to do this, especially when you're working with customers closely and along the way, because they need to understand the kinds of inputs and outputs that are going on. When you're doing your requirements engineering, you're basically populating the input-output process tables, right? Another thing that's happened is that people get stupid and goofy copying and pasting from Stack Exchange or GitHub. And so they have single letter variables. Do not even once in this course, show me code that doesn't have a sensible name, some indication of data type, and some relevant sense of purpose in the name, okay? If I see a single letter variable, I will have a meltdown and it won't be pretty. Now I'm dramatizing here, but basically the expectation here is, let's say I'm a customer and I'm paying you big bucks to develop a solution that I am going to have to maintain in-house. If I had $1 for every time I had to maintain code that was written by somebody else that had X or I equals, I could vomit $100 bills and still be a billionaire. It's just that big a problem, okay? So just, one way to show your maturity as a software engineer is to have really good naming conventions for variables. And so one of the criticisms of adaptive and agile versus old school program planning and documentation models is that the old school guys like me like to throw stuff around the room when they're looking at code for people who are producing adaptive or agile methods, and that has nothing to do with the method. You need to make sure that regardless of the method that's chosen, that everybody agrees to this kind of thing. Flowcharts to frame logical criterion reference conditions with suitable decision points. Pseudocode to articulate the flows of process for a given method. Why? Because you find out when you prototype in an interpreted language and then you port your concepts over to a compiled environment. The pseudocode helps you when you like recreate for production. Does everybody understand the difference between like demonstrating a prototype in an interpreted language like Python versus production when you create it in something like C++ and then it's compiled for efficiency and performance? This is one of those things that is kind of an industry standard. Oh, when we're doing demos, it's quick and dirty. When we're demonstrating final results, it's written in C++ or it's written in Java. It's written in another more structured environment. It's easier to support long-term. Visual mappings for data set relationships, SQL joins. Has anyone here been part of CSC 239, Scientific Computing Applications? Anyone? Has everyone here had CSC 245?
Yeah, I think so.
Yeah.
Okay, database. Did you remember or recall a part of your class activity? You had screens where it showed the tables and it had links between the tables to so it would reflect the nature of the joins between the tables. Doesn't MySQL do that? Yes, no, maybe?
Yeah.
Okay. That's another thing that's very helpful when you're mapping out the data tables. So one thing you want to do is make sure that you have clear documentation and visual mappings of the data set relationship. Let me show you a quick example here of, let's see, in here, solutions. Yeah. Okay, this is good right here. Open with photos. Can everybody see my screen?
Yeah.
Okay, this is in Microsoft Access. So you could develop a solution using .NET and Visual Studio, and you could use the Office 365 suite and use Access to create forms and front ends and develop other components, other graphical components in the Visual Studio environment, but you also have the backend SQL Server, Microsoft SQL Server, which is kind of like Oracle or MySQL. In any case, prototyping and quick demos, you can stitch a series of tables. So here you see small t. Can everybody see that small t?
I can.
Okay.
Yeah, I can see it.
Yeah, I know it's kind of faint, but why do I put a small t? Well, that's my own shorthand that represents what kind of database object I have on the screen. That's a table, T for table, Q for queries, right? F for forms and so on. And then the name that I'm using is descriptive, so I know something about it. Same thing with variables. That's the standard we want to encourage here. I just wanted to give you a glimpse of something you'll be required to share during later prototype demos, deliverables. I want to see something like this. Now, you don't have to use Access. You can use MySQL. You can use other development database, relational database management systems to create this, but that's another component that's important. And it doesn't matter whether you're adaptive agile or you're planning and document. You will still have to provide some references so people can maintain and troubleshoot and support your code. And then of course, self-documenting code. So what do we mean by self-documenting code? You have a statement and then you remark out quick guidance or quick details about what it is somebody's looking at, right? I should not have to guess what I'm looking at. And if you can't explain it, that's a sure sign that you're a cheater and you like to copy and paste stuff from online instead of developing something authentic. Of course, you can always take something online and modify it and pretty it up and run some quick tests to make sure it's appropriate. So the focus changed from designing original custom code for a given purpose to reusing code objects, hunting and gathering versus building. This is one criticism that traditional old school types who love planning and documentation models, they criticize the adaptive and agile folks. And that's sad because good programming methods have nothing to do with the software engineering model. What we have are a bunch of subject matter experts that pull together in an adaptive team, and they're very capable and they're each very good at what they do, but somebody doesn't say, hey, we still got to know what's going on. And what happens if you're killed next week in a car wreck? Which other member of your team is going to be able to take over and finish your part of the coding for for those components, right? Seriously, right? So what am I saying? Depending on the institution that's hiring the software engineering team for the contract, it's in the hands of the people who are your customers. They can demand this. But I'm saying you'd be doing everyone a favor if you knew that there were certain things you got to do the same no matter whether you're old school or you're adaptive, okay? That's the main point. So custom solution development has been wrongly portrayed as a costly, labor-intensive process by uninformed managers. So you can turn everything upside down. For this reason, coding preparation techniques have not been supported as much as the search and selection of commercial off-the-shelf solutions assembled from coding pieces. This makes unfamiliar code an effective way to embed cybersecurity exposures. That's another downside of this modular bolted-on approach, right? And these practices can end an otherwise promising career in computer science and software engineering. And so here's a link. Yes, believe it or not, a software engineer paid someone else overseas to provide the code so that they could pass it on as their own work. And it ended badly. I'm just saying, these are pitfalls, right? So when we're summarizing the origins and the good, the bad, and the ugly of software engineering, I just want you to know about some of this stuff, right? So certain essentials still matter. Appropriate preparation for coding, whether it's predictive or adaptive. So predictive is another term for planning and documentation. Let me say that again. Predictive means P&D. When you plan and document with a software engineering model, in a sense, you're laying out and predicting how the solution will look when it's finished. I don't know if that makes sense, but so as opposed to an ongoing process where you're refining all the time until you get it just right. Does anyone know the story of Goldilocks?
Yeah.
And the three bears, Goldilocks.
Yeah, I know.
Has anyone ever heard that story, the nursery rhyme story?
Yeah, I have.
Okay.
Yeah, I heard of it.
So this Goldilocks needed a place to stay, and she found the home of some bears, a family of bears. And she kept going from one bear cave to another, and she found out it was too hard, too soft. Well, she went around in the house and she kept trying to find food to eat and places to sit and where to sleep. And it was too hot, too cold, just right. Too soft, too hard in terms of a bed, just right. And the point I'm trying to make is adaptive by nature is more like the Goldilocks thing, where you're like, is this better or is that better? Has anyone ever done an optometrist examination with your eyes? Have you ever noticed how they start? They're like, okay, from what we can tell, you're as blind as a bat, but is this better or is this better? They kind of put it in front of you. So adaptive means you're going to be changing stuff all along the way, but that doesn't mean you shouldn't keep a record of what you're doing. Documenting your changes along the way is important so that you can go back and fix problems as they arise. The fact that now predictive, the goal is to have the plan, stick to the plan, drive the plan, and if somebody can't do it, get rid of them and get somebody who can do the plan. So this one is really kind of, that's really hard on people. This one's really fun, but there are problems. And I'm just overgeneralizing here. So if you mind some of these things, regardless of which type, you'll do well, right? Exercise primary key discipline consistently. In particular, avoid the use of personally identifiable information as a primary key for any data set table. What am I talking about? Can we go back to this? Can everybody see the screen?
Yeah.
Okay, so an auction ID, a bid ID, a bidder ID over here. That's a random number that's automatically assigned and it increments. It's an auto-incrementing data field in Access. So as you add bidders, the ID number increments by 1, but it's not their social security number. We don't use the social security number of the bidder, right? We don't use the business license number for the auctioneer and the auction venue. The point is you don't want to use personally identifiable information. These are things we'll revisit at a future time, right? But I just wanted to explain that a little more. Use dedicated, unique auto number fields for each data set and table, and that enhances the data set and table security as edits are readily detectable and the index the efficiency of searches and queries increases by an order of magnitude. By order of magnitude, we mean like 10-fold increase. So if you take information as a general rule, the specific data criterion and attributes you need to incorporate in your integrated solution, and you break your data tables down into the minimum amount of information required in each data table. And then for additional stuff you need to look up, those are in different tables, right? You could have a medical records table, you could have a patient table, and a patient number is referenced in the medical records, but that's the only information that comes back to a patient identity, right? This is called normalizing your database. So it's like the first, it's the first level or foundation of data normalization. If I'm hoping these terms kind of ring a bell. If you had CSC 245 and or you had CSC 239. Structured data sets and tables with the least number of fields and the smallest data type. So what do we mean by smallest data type? Let's assume that I need to track I need to work with IDs, and those are integers. Is everybody familiar with single and double forms of, depending on the size of the records you have to use, there's a greater range, a greater number range associated with different data types? Or am I thinking of floating point? Inside, all right, so the point is that oftentimes people will use memo instead of text, and then there's a huge amount of data memory, disk, and RAM reserved for a given amount of information. If a text field will do, and you only need up to 255 characters in a text field, you should be using the text data type. I'm specifically talking about this context and this particular database system. In MySQL, they may call it something different, but in Access and SQL Server, you can say, okay, I have some written and Word information I need to store, and you have to make the choice. Would a text field that's limited to 255 alphanumeric characters be appropriate? And do you have to use all 255? No. What about a street address? Do you need 255 characters of space for a street address? Hello? How many people need 255 characters to write out the street address of your US postal? I mean, nobody does, right? Not really. So the point is that there are simple practices in software engineering when you're working a project. You got to get everybody on the same page. Why? Because if one of your developers in the team, one of your software engineers in your team is using a memo field where you can store 100 pages of textual information versus 255 characters of information, that creates all sorts of problems. So standardization and a efficient minimal approach is really a very helpful thing, right? When you use larger data types than are required, you're basically setting up a football field for hackers to play with. So it's considered a better way to code. Surplus memory, if you're setting aside or reserving surplus memory, whether it's sizing your variables or your choice of data type in a database, you could be opening a door that allows a malicious actor to have plenty of breathing room to do things that make your code unsafe. So these are best practices regardless of software engineering model type, okay? And when I say database planning and design, I'm not talking about planning and documentation SE models. I'm talking about the database planning and how you architect a database solution, regardless of whether you're using P&D or adaptive, predictive or adaptive. Any questions? So
I'm okay.
Okay, so preserve referential integrity via the configuration of joins or table relationships. This prevents cascade purges of data records. If I go back to this, when the relationship or join is established between these two tables, in its properties, I can specify I can enable referential integrity, which means if there are records in the bidder breakout table that use auction statistics or auction ID criteria, I can't delete a record in here that has a primary component in here. So those are, we'll get into this more later in the project phase of our course. But one of the things you want to understand is that referential integrity keeps everything from going boom, especially if you have different software engineers building out different portions of the enterprise database, right? So if there are changes that are made to the bids table and there are cross-referenced elements in the auctions table, enabling referential integrity means you can't make a change that would spill over into another table. And of course, that can get tricky, but it saves you and your customers a lot of headaches. Does everybody understand what I'm talking about here? Yes, no, maybe, or you're seeing this differently for the first time?
I understand.
Okay. I can provide an example if someone would like to see an example specifically. I can open up access. So use a suitable naming convention. We were talking about this before. Use it for your database objects just as you do for variables, right? When you're initializing, when you're establishing a variable, it should use a suitable naming convention for the variable ID. And by the same token, whenever you use it, there's a lot of database components to an integrated enterprise solution. It is useful to work with common relational database management system applications like Access and SQL so that you can rapidly prototype table structure. And then when you go to production, you can work alternate coding in a full-scale IDE and basically work SQL statements to do it. One very cool thing about Access is that if you work a quick query graphically, and then you want to see the SQL code, you can click a single button and all of the SQL statements that are required to work a specific kind of query are right there on the screen. And those you can copy and paste into other environments. That's really cool. So that concludes our review of our Module 1 study guide. Are there any questions about the content we just finished in our Module 1 study guide? Okay. I'm going to stop sharing for a moment, or pause sharing and pause recording. Let's take a 2 to 3 minute break. Give everybody a chance to stand up, stretch your legs. No basic review of software engineering essentials would be complete without mention of a pioneer in this discipline by the name of Brooks. Okay. So Fred Brooks was actually awarded, he's basically been awarded all sorts of honors, and he came up with this essay on software engineering. It is one of the original concepts, and this was, of course, quite a while ago. So if we're looking at the first published in 1975, and then in 1982 to 1995, right? In that time frame, planning and documentation models or predictive software engineering models were really large and in charge. And he was a former employee of IBM. But one of the things that he understood is that when you get a team together and they're each developing different components of a large solution an entire organization uses, and back in the day, that's what an IBM mainframe was, right? You would run into problems. And one of the things that we said was a, a, a legacy challenge for planning and documentation or predictive models is that they were what? Over budget, and they cost too much. So it took too long to do, and it cost too much. And this was one of the criticisms of planning and documentation or predictive software engineering models, first generation collaboration models for programming teams. Now, what was Fred famous for most? I have added this link to our references folder, and I want to call this out. So in plain terms, Fred Brooks studied what happens with planning and documentation or predictive software engineering models. And what was more often the case is that everything was taking too long and too much money to finish in terms of a development project. And so there were all sorts of efficiency experts, investigations and research conducted to determine how best to, if your ox is in the ditch, how do you solve a problem? The federal government wants a new software platform for the Internal Revenue Service so they can do tax returns more efficiently. And there was probably a corporation that has several corporations that have developed integrated solutions for the Internal Revenue Service of the US federal government so they can do income taxes and screw the little guy that much more efficiently. I might have to edit that out of my YouTube. Anyway, because I don't care to be audited this next year. All right, in any case, and I hope if any IRS employees are tuning into this YouTube video that they have a sense of humor, because that was basically meant in jest. In any case, there would be plenty of federal agencies that would have similar challenges. The Department of Defense, the FBI. In fact, one of the most famous failures in recent times was a project under the Department of Homeland Security after 9/11. They wanted to integrate all of the criminal records among law enforcement agencies in the federal government. And it turned into a quicksand, tar pit, black hole of death for, it never got finished. Never got finished, okay? And very large, very profitable corporations who normally do really good jobs at things failed miserably. I'm not mentioning any names because I don't want their lawyers hounding me. In any case, Fred studied what happens when you have a project that lags and somebody says, hey, let's throw more money at it. You know why this is taking too long? You don't have enough help. That makes sense, doesn't it? How big is your programming team? 4 people. Really? And you got to get this all done how soon? 4 weeks. Holy buckets. Oh, no. Well, where are you in the project? Well, we just finished our requirements engineering. And we're not quite to the prototype developments or the prototype demos, right? Okay, we'll add 3 guys or 3 girls or 3 people, 3 professionals, and we're going to jumpstart the prototype demos, right? And here's the problem. Guess what the team does for the next 2 weeks with those 3 new teammates? Guess. Would you care to guess? And Dr. Brooks became famous for he basically studied this exhaustively, and then he published about it because people kept hurting themselves. For the next 2 weeks, the original team spent all their time getting the 3 new hires up to speed where they could even help at all. I don't know if this is common sense, but there are times when I would like to distill and break down all of the 400 level complex jargon that you find in some textbooks. And I basically want to keep it simple. You'll even see here that Fred Brooks has a formula to calculate just how broken and stupid things will get. But one thing he did do is he quantified what happens when you have 50 developers. You have 1,225 channels of communication. In theory, because if each one of the 50 developers has the capacity to interact with the other 49 developers, it's a simple mathematical formula, right? And it gets to be pretty crazy pretty quick. That's the thing that he proved. And efficiency experts said, well, you can measure how much work can be performed by an average worker in 1 hour, and that's called a man hour. And a man month is like an extension of that idea. So the idea is, okay, we're going to add more people and things will come out faster and better because we add more people. And it's a load of manure. It doesn't work that way. You can't do it. When you start adding other people to solve the problem, it turns into a freak show. And a Fortune 100 company that is one of the largest Department of Defense contractors went off the rails and nearly ruined their reputation when they tried to do the integrated criminal record federal project. It is like just as bad as the $300 million rocket that exploded. So what's the whole point? What's the kernel of truth in Fred Brooks's Mythical Man Month? It's that, okay, this is a complex process. You can't just throw more money and more people at it. That's not going to make it go faster. In fact, there's a very great potential that if you do this in midstream, if you make changes in midstream, it's going to make matters much worse. It's actually going to delay things further. This is a hard sell for software engineering professionals to educate finance and administrative people about. But you need to be able to speak in plain terms about how this works. So when somebody you are reporting to or somebody a customer you need to explain, and they go, hey, just add more. You're like, no, that's proven to be a very bad thing. You need to cite Fred Brooks' work. You need to explain a project running behind schedule will run even later if you add more programmers, right? Assigning more programmers to a project running late makes it even later because it takes more time for the new programmers to learn about the project, and the increased communication overhead will consume an ever-increasing quantity of calendar time available. So what happens? You're even further behind. Then someone really in charge, like the head honcho, comes along and he goes, I'm going to fire all of you if you don't get this done by the end of this week. And then they hire like 6 more people, and it's horrible. Now I know I'm being dramatic here, but look at this. See, if you understand this method and you understand the implications, you can improve your productivity significantly, right? And it doesn't mean throwing more money or more programmers at it. Sometimes it means working differently or more efficiently instead of just working with more people, period, okay? Any questions about the Mythical Man Month and what it actually means? Okay. Has everyone taken the time to view these first 3 sections? There's actually some, these are short. There's some quick information in here. I would recommend watching right from here to here. If you have not yet taken the time to watch these videos, how about we close early today and you use that time to get started and do this. If you haven't done it already. Okay?
Appreciate
good.
that. Thank you.
Okay. In fact, I think there might be something in here about Fred Brooks inside here. That's really small. Anyway, there is mention of Fred Brooks along the way here. Stop when you get to 1.4, software quality assurance and testing. That's another topic for another time. Okay. Are there any questions about what we've done to this point? I have posted the links. I have the last link here. I'm going to post it as soon as we stop for Tuesday's session, and then I'm going to push today's session out there. I will put the first version of the Module 1 assessment online before the weekend. And when is it due?
The 24th.
The 24th, which is next
The
Tuesday.
next,
Right here. And can we push back and postpone if we need to? Nope. Why is that? Because we want to finish the review we want to conduct our item analysis of your initial attempt in class on Tuesday at 3 p.m. And then we want you to reconcile and retake it by the end of the month. So we want to be completely fresh and strong on every aspect of Module 1. Now, when we finish our item analysis of the first attempt of the Module 1 assessment, as soon as we finish that, and that should only take 15, 20 minutes, not a long assessment. As soon as we finish that, we're going to pivot and get into Module 2. We're going to deep dive into legacy models, predictive models, planning and documentation models. They're all called the same thing, okay? So predictive. I just want to remind everyone, I will revise. You'll see revision 1A. I do plan to change the wording in that one paragraph to say it is true that these five stages of activity exist in predictive early models, and then the newer adaptive models just the same. They might have a different label, but they're pretty much the same. We started off in class talking about that. Okay, so I'm going to stop sharing. I hope you have a great weekend, and please use the remaining time to start diving in. This is really interesting stuff, and it's well done. So we'll see you then, and good luck on your first attempt at the Module 1 assessment.